Welcome to this introduction to eSIM. In this video we'll be looking at what eSIM is, the benefits of eSIM and also its market adoption. So let's start with, what is eSIM? Well, the best way to figure out what eSIM is to look at the SIM card itself. Why do we have a SIM card today? Essentially, it is to do with determining who is using the device so that they can be charged for the services they are using on a mobile network. The mobile operator distributes the SIM card to the customer of the device. The customer can either get the SIM card from a retail store or maybe they have one delivered to them. The SIM card is actually a mini computer. It's got memory, it's got a processor, and it runs applications. And most importantly, it has some secret information that's stored on it by the operator. The red dot on the SIM card signifies that the data on the card relates to a particular operator. Other colours signify data relating to other operators. When the SIM card is inserted into the mobile device, it is used to identify and then authenticate the customer to the operator's network so that they can be charged for the services used. Now, the customer might have more than one SIM card, but of course the mobile device can generally only take one SIM card at a time, so the other SIM card would probably be held in the customer's wallet or purse. Moving on to eSIM then, the only technical difference is that the SIM card itself is no longer present, but the data that was on the card, again signified as a coloured dot, is downloaded over the internet into the customer's device directly. When the data is received in the mobile device, it has to be stored somewhere. Now, we cannot use the conventional memory of the mobile device to do this because it's not secure enough and could be hacked. So instead we have a special eSIM chip in the device called an eUICC to store this data. Now you can see here that we have 3 eSIM profiles stored on the eUICC from 3 different operators, red, blue and green. The eUICC can actually store any number of eSIM profiles, limited only by its memory size, and typically one of those profiles will be marked as active. This chip then operates in exactly the same way as a physical SIM card inserted into the mobile device, and it is used to first identify, then authenticate the customer to a particular operator's network. It's worth at this point having a quick look at the differences between physical SIM cards and eSIM profiles in terms of how the customer interacts with them. For physical SIM cards, there are 3 main actions: inserting a SIM card into the device, removing the SIM card from the device, and then eventually destroying the SIM card once it's finished with, typically by taking a pair of scissors and cutting it in half. When we look at the corresponding actions with eSIM profiles, enabling an eSIM profile is the same action as inserting a SIM card, and you can see here in the diagram that profile 1 is currently enabled, meaning that it is active. Disabling a profile is the same as removing the SIM card, and deleting a profile frees up space for other eSIM profiles to be downloaded. Let's now have a look at the main benefits of eSIM then, and we split these benefits into 2 main markets. First of all, the consumer market, and then we'll talk about IoT, Internet of Things. So in the consumer market, let's talk about device activation. If you want a SIM card, you'll need to get it from a retail shop, or you can wait for one to arrive in the post. And of course, when the SIM card does arrive, you'll need to make sure that it's the right sized SIM for the device you have. And there are 3 sizes of SIM card available today: the standard or mini SIM as it's known, the micro SIM, and the nano SIM, which is the most popular size today. In the eSIM world, things are far simpler. All we have to do is scan a QR code with the device that is to be connected, and then the SIM profile is automatically downloaded into that device. So there is no need to go to a shop anymore, and there is no need to wait for something to arrive in the post. And of course, there is no need to worry about having the right size of SIM, especially when transferring between devices. For the devices themselves, of course, there is a SIM tray in the device for the SIM card, but this is effectively a hole inside the device, which makes it much more difficult to make the device waterproof. And of course, when the SIM card is not in the device, it is very easily lost. If we were to look inside the device, the space taken up by the SIM tray is actually quite large relative to other components in the device. It's almost the same size as the main processor, and that is space that could be used by the device manufacturer for other things. In the eSIM world, there is no SIM tray requirement anymore because there is no SIM card, and this allows for much smaller devices to be manufactured. Devices like smartwatches, fitness bands, or even smart identity badges for lone workers. It'll be interesting to see what new device categories appear as time goes on. And because there is no more any SIM tray, this means devices can easier be made waterproof. And the space now freed up inside the device can be used for other things, including new functionality or even a bigger battery. And then thinking about the logistics of handling SIM cards, well, actually for the operator it's quite expensive. They order millions of SIM cards every year, which typically get delivered to a warehouse in the country of operation. And then from there those SIM cards are distributed to each of the retail shops. The logistics are expensive and quite problematic for the operators. In the eSIM world it's very different. The eSIM profiles are generated, then stored on a central back-end server called an SMDP+, which is operated by the network operator. Then, as required, these profiles are delivered by the SMDP+ to any mobile device anywhere in the country of operation, or even worldwide for the larger operators. And then there's an environmental saving because at the moment 6 billion SIM cards are produced every year. When eSIM is prevalent, all of that waste disappears. There is an additional benefit of eSIM in consumer devices, particularly smartphones, and this is called dual SIM or DSDS. Prior to eSIM, most devices only had a single SIM slot, allowing it to be connected to a single network. With the advent of eSIM and device manufacturers knowing that operators in some countries will take time before they are eSIM ready, eSIM-enabled smartphones will still include a physical SIM slot in order that the device manufacturers can still sell into those countries. The existence of both an eSIM and a SIM slot in the same device allows for two network connections at the same time. And going forward, when all network operators support eSIM and the SIM slot disappears from devices, it will still be possible to have two network connections via two eSIM profiles. This brings about many new use cases for the consumer, including separation of business and personal subscriptions on the one mobile device, and low-cost data via a travel subscription, while still receiving calls on their main number when on vacation or business abroad. Let's have a look now at some of the benefits in IoT. And this is where the development of the eSIM specification really started. If you look at the IoT environment, what you see here on the screen is a typical wireless module used in IoT devices, and circled you can see the eSIM connector. This connector has some spring-loaded contacts which make contact with the electrical plate of the SIM card when inserted. This allows the device to communicate with the SIM in order to get the device onto a mobile network. The problem is that in some IoT environments, for example in agriculture, there is a great deal of vibration and even some instances of shock. When this happens, the spring-loaded contacts may disconnect from the SIM card momentarily, and that's enough to cause problems with the device. And, just with consumer devices, because there is a hole in order to insert the SIM card, this can cause problems with humidity, for example in the case of an IoT water meter at a reservoir. In the eSIM world, things are very different. The EUICC is soldered into the device, and because of that, the device can be hermetically sealed. That way we avoid any vibration and shock issues, and we avoid any problems with humidity. If we now look at the production of IoT devices, and for the example here we are using the production line at a car manufacturing plant, today with physical SIM cards there has to be a stock of cards for each of the countries that the cars will be shipped to, and at some point during the production line the correct SIM cards will have to be fitted into the right cars. This is logistically complex for the car manufacturer. With eSIM though it's very different. All of the cars will have an EUICC built in, and this will be the same part number for each car, no matter where the car is going. Then at some point, near the end of the production line, an appropriate eSIM profile for the country the car is being shipped to will be downloaded into the EUICC for that car. And in fact, this does not even need to be done on the production line. The car could be shipped first, and then an eSIM profile downloaded into it in-country. Finally, one other primary benefit for eSIM for IoT is changing operator. Consider here an energy supplier that is supplying electricity meters all over the world. At the moment they're contracted to the red operator as signified by the red dot on all the SIM cards. Now, if that energy provider wants to change operator at the end of their contract, it's very difficult for them to do that because they're going to have to send an engineer out to every one of those units to change the SIM card. And there could be millions of these units, and so it's cost prohibitive. But with eSIM, things are very much easier. The energy provider can now negotiate a new contract with, say, the Blue operator, and this operator would download Blue eSIM profiles to all of the units. It might take a few days to do 1 million units, but that's far easier and cheaper than it would be with physical SIM cards. Finally then, let's have a look at the market adoption of eSIM. What you can see here is a chart of consumer devices that are available today. This list is growing all the time, so it's likely to be out of date already. You can see that all of the main device manufacturers support eSIM, and many of those are supporting eSIM in their entire product range. The graph you see here is from the GSMA, which is the trade association for mobile network operators all across the world. GSMA predicts that by 2025, a third of all smartphones will be using eSIM to connect to mobile networks. And if this is the case, it's likely that maybe only 3 or 4 years after that, nearly all mobile devices will be using eSIM instead of physical SIM cards. eSIM is coming, and it's coming fast.